Hello friends, in last episode we have already started eigenvalues. In today's episode we see how to calculate eigenvectors. As usual, start from theory, which is very important in MPSC civil exams. Okay, let's start. What we have given? The equation, which is very important to find out eigenvectors when there is x is present and a minus lambda I is for eigenvalues. We know that for finding out eigenvalues and eigenvector we have square matrix. Okay, in that what is A, which is a given matrix, lambda is a constant, I identical matrix, x unknown matrix, and 0 is the null matrix. Okay, a matrix A minus lambda I is called characteristic matrix of A. Only A minus lambda I is characteristic matrix of A, whereas determinant of A minus lambda I is called characteristic polynomial of A. Equation determinant A minus lambda I is equal to 0 is called characteristic equation of A. When is equal to 0, characteristic equation. Only determinant characteristic polynomial of A. If lambda is the characteristic root or eigenvalue of n into n matrix A, then x non-zero vector such that x is equal to lambda x is called eigenvector or characteristic vector. Set of eigenvalues of A called as a spectrum of A. Now, relation between eigenvalues and eigenvector. First, lambda is eigenvalue of a matrix A if and only if that there exists a non-zero vector x such that x is equal to lambda x. If x characteristic vector where lambda is a characteristic value, then kx is also characteristic vector whose characteristic value lambda. But here k is non-zero. If x is an eigenvector of A, then x cannot correspond to more than one eigenvalue of A. Eigenvector of a real symmetrical matrix corresponding to different eigenvalues are orthogonal. First problem. Find all eigenvalues of a given matrix and also find eigenvectors of a matrix. 2 by 2 matrix. Start from simple. We will see 3 by 3 matrix also. 2 by 2 matrix. Matrix A is equal to minus 2, 1, 12, minus 3. In last episode, we have seen tricks to find out eigenvalues of a given matrix. But in this episode, we will see both methods which are usable by A minus lambda I after finding out the determinant of A minus lambda I, and in the last episode we have seen the tricks which is also used in this lecture. Let's see. First we have find out eigenvalues of A. Okay, for that we have characteristic matrix of A A minus lambda I. A given matrix minus lambda into I identical matrix. Then it converts here lambda, when it take minus 2 minus lambda and minus 3 minus lambda. See this matrix. Now what we have to do? We have to take a determinant for finding out values of lambda. Take a determinant of this matrix. How to take determinant? This term into this term minus product of this term. Okay. Then see, minus 2 into minus 3 minus lambda and minus lambda into minus 3 minus lambda minus 12 is equal to 0. After calculation we get lambda square plus 5 lambda minus 6 is equal to 0 minus 6. The product is minus 6 and the addition is 5. 6 into minus 1 minus 6, 6 minus 1, 5. Then values, lambda is equal to minus 6, lambda is equal to 1. This is a tricky formula. Lambda square minus S1 lambda plus determinant of A. We know S1 is addition of a minus and determinant A. Same equation and the same values. Now we have formula for eigenvector. A minus lambda I into x is equal to 0. Now put lambda is equal to minus 6 and lambda is equal to 1, which are eigenvalues, and find out eigenvectors. First we take lambda is equal to minus 6 in this matrix and then lambda is equal to 1. We can solve alternately or simultaneously also. Here I have taken lambda is equal to minus 6 and lambda is equal to 1. We solve simultaneously. Lambda is equal to minus 6, then minus 2 minus 6 means plus, what we get, 4, and here minus 3 minus 6 means 3 plus 3, and these two values are remain same. Hence we get this matrix. When lambda is equal to 1, minus 2 minus 1 means minus 3, and minus 3 minus 1 means minus 4. Now we get this matrix. See, 12, 3, 4 into 3, 1 into 3 get cancelled. So what remains? 4, 1, x1, x2 is equal to 0. Here also, if R2 plus 4 are 1, then only one row is remaining. Now very simple, 4x1 plus x2 is equal to 0. Here also minus 3x1 and 1x2 is equal to 0. 2 is equal to t, x2 is equal to t. 4x1 is equal to minus x2. Here minus 3x1 is equal to minus x2. Now x1 is equal to x2 by 4, minus x2 by 4, but x2 is t, and here x1 is equal to x2 by 3 means t by 3. We can rewrite these eigenvectors as capital X is equal to x1 x2 is equal to t common minus 1 by 4, which is a value of x1, and value of x2 t when t is take common. Same, x1 t by 3 means 1 by 3, t 1 and t is common. 3 by 3 matrix. A is equal to 1 0 minus 1 1 0 0 minus 2 2 1. We have characteristic matrix of A is equal to A minus lambda I. Hence 1 minus lambda, 0 minus lambda and 1 minus lambda. Remains are same. Now take a determinant of A minus lambda I for eigenvalues. 1 minus lambda into product of minus lambda, 1 minus lambda minus 0 into 0, then all values from this 0, minus 1 into 2 minus plus 2 lambda, but 2 minus plus product, but minus sign, 1 means 2 minus 2 lambda. Okay, solve. 1 minus lambda into product of minus lambda plus lambda square. In that we can take 2 common. See, 1 minus lambda, 1 minus lambda. Take this common. Now solve this lambda square minus lambda equation. We get 1 minus lambda, lambda square minus lambda minus 2. Hence we get from these two values, what's lambda minus 2 and lambda plus 1. Hence lambda is equal to 1, lambda is equal to 2 and lambda is equal to minus 1. Very simple. Put lambda is equal to 1 in A minus lambda I, then find out the values. We know how to put the values. Okay, let's see. When lambda is equal to 1, 1 minus 1 0, only minus 1, then minus 1 and 1 minus 1 again 0. We can reduce this line after R. Okay, very simple. x3 minus x3 is equal to 0. Now x1 minus x2 is equal to 0. x3 is equal to 0. x1 is equal to x2 is equal to t, then x1 is equal to also t. Rewrite. Now lambda is equal to 2. We get this matrix. See, we can't reduce it to echelon form. 3 equations, hence we have a rule. See, x1 means this x1 and the minor of this minus x2, then cancel this, 1 minus 2 0 minus 1. Now again x3, 1 minus 2 2. We get these values. Minus 2 into minus 1 is equal to 2 and minus 0. Same, rewrite as C. x1 2 2 minus 1 and 2. When we divide it by 2, here 1 by 2 minus 1 by 2. Okay. Same when we take lambda is equal to minus 1. We can solve this for calculation C. Pause the video and see the values. Thank you.